Hey everyone, welcome back. So today we are going to deploy a complete MLOps solution in Azure end to end. So what does that mean exactly is that we are going from zero to having an Azure infrastructure provision by Bicep for dev and prod environments. We'll have a model change classifier deployed in Azure Machine Learning Workspace. I will explain what the model is in a moment. We have a pipeline with reusable components for data preparation and for training of model. We will serve the predictions for that model using a managed online endpoint. And the most important part is that all these components will be automated using GitHub Actions workflows. So no manual work, no portal, no notebooks, everything will be handled by GitHub Actions. This is the full picture of our architecture, a dev workspace and a production one. We have the main orchestrator, which is GitHub Actions. With Bicep, we will deploy this architecture using an OpenID connection to Azure. And also we have a GitHub Actions workflow to train and register the model. We have a quality gate in the workflow to validate when to register the model and when to ignore it. And the workflow will also create the managed online endpoint and then the deployment itself. Once we want to promote this to production, we will download the model from the machine learning workspace in dev and then register in the production one, and the workflow again will create the endpoint and finally the deployment. We are doing this approach because this is a demo, but in a real world scenario we will share a registry where we push this model created in dev into that registry so other workspaces just pull them. Before we start, make sure that you have an Azure subscription with contributor access. We need a GitHub account with a repository that is ready. In our case, we are using the infra and the model artifacts in the same repo, but in a real world, we will have the IAC handled by a different team, and the code for the model should be managed by another team and in another repo. And finally, an Azure command line utility installed locally. Before we deploy anything, we need to connect GitHub to Azure, and we are going to do it the right way. We are not going to store any credentials in our repo. In this case, we are going to use OpenID Connect with a federated credentials, which basically will tell to Azure that it should trust our repo. In the past, I have used client secret and client ID, but in this case, we will only need the client ID, subscription ID, and the tenant ID. To do so, you just need to create a service principal or an app registration, and you go here into clients and secrets. And in this part, you can add the credentials that you need. So you should add the repos. So I added it for pull request, for the environments, and for branches too. But you could decide how to do it. Once you have that, you can come here into GitHub, and in the secrets and actions, you can just put these three, and that should be enough for GitHub to authenticate to Azure. The next part that I want to show you is the infrastructure as code. In our case, we are using Bicep, and we have these files that deploys all the infrastructure. We have the main orchestrator file, parameters for each environment, dev and prod, and finally one module for a workspace, which in this case will deploy more than one resource because it requires that. The first one is the main.bicep. This is the entry point for any Bicep deployment. We define the parameters, and we only have in this case one module. So this is the workspace module, and we pass these parameters that we are getting from this one. Those parameters will change depend on the environment. This is what we have for dev. Basically, it changes only the name for the workspace because I decided to use the same size for dev and prod, but in a real world, dev should have a lower tier and production should have more powerful machines. But in this case, it's just the names. We are deploying to ECS2 region, and this is the name that we will give to the production workspace. Moving to the workspace module, it's where the things get interesting because we have defined different resources. In this case, we have 5 resources, including the compute cluster. So the first one is the storage account. This is used by the Azure Machine Learning Workspace to store the training data, the model artifacts, the MLOps, and so on. We're using a local redundant SKU. There is another resource that is required to store the secret, which is the keyboard, and the application insights is also required to monitor and log in the workspace. You need to track the performance of the model, the endpoint latency, and so on. And finally, the container registry, which will store the Docker images that we build during the training or inference environments. We have 2 resources, the Azure ML workspace and the compute cluster. This is the compute cluster is with the training ROMs. We have a cluster which we have the minimum and the maximum. Minimum in our case is 0, so when there is no training data, there won't be idle compute, so it will scale down to 0. And the workspace is basically using a system assigned identity, and we need to specify all the properties that we just defined above. Now let's see how those Bicep files get deployed, because we have a GitHub Actions workflow for that. First thing that we notice is the triggers. We have only when we modify the infra path. And also we have an option to enable this workflow to run manually. We have this permission for the OpenID Connect to generate the token. And here is where we start logging with the OpenID. If you see, we only have client ID, tenant ID, a subscription ID. We then create the resource group. We do a linting with a built-in command. We validate the same using the main.dev. This is going to be executed for the dev resource group. That's why we are passing the main.dev bicep parameter. The main.bicep is gonna remain the same for dev and prod. The only thing that changes is the configuration that we pass to the main.bicep. And this is the cool part here, which is a what if command. This is like similar plan. This will show what is going to be created, destroyed, or updated without actually applying it. We do that. We create a string to then, in this step, we will take that string and put it in the pull request description. So that's basically what it is doing. Once we complete that and we get into this dev deployment, if it needs to be executed from the main branch to be able to deploy it, this is for pull requests only. And we do the same. We do authentication and we deploy this bicep command using the AZ command line utility. The only thing that changes here again is the param file. For the production, we have the same change, but we have like a sequential. We need to wait for the dev environment to be completed. That's why we have this. And then we start the deployment of the production one. Also, the production one is using the environment prod. If you see the one that we did for the deployment to dev was environment. And for the production one, it's production. This will allow us to, for example, for production, we have a manual gate to approve this deployment. And the other steps are the same for dev and prod, just changes the parameters. Now let's look at the customer churn classifier model. This is the data set reference that we have. And basically a customer churn rate is the percentage of user or subscriber that a business loses over a specific period of time. So we will be using these hyperparameters to the random forest. And this will be the features that the model will use to predict if it is a churn or not. And this is the formula that I took from internet to predict that. We have the expected metrics, we have accuracy, F1, precision, recall, and this last one. Now let's take a look at the training and preparation code. So in our case, we are using these two reusable components. Preparation of data is self-contained. We don't have any external dependency. In a real world, we have this data in another source, and then we reference it using a data asset in Azure Machine Learning, and then we do the manipulation here. But for this demo, this works. So we are generating the data, and we are computing the churn score based on the formula that I showed in the reference. Now for the training, we are using MLflow. We are using random forest classifier, and we define these 5 metrics to evaluate. These are the features that we will be using to predict if it is churn or not, and the target column. And also we define this data structure to specify a quality gate of what are the expected thresholds that we want for each of these 4 metrics. In this part, we specify what are the parameters for the model, the estimator, the dev, and so on. And here is where we do the training. Later, with that data that we just predicted, we will compute the metrics that we define above. And then in this part, we will evaluate those metrics to see if they met our thresholds. If they met, they will give us a pass, and then we can register the model with this name. And if not, then it will only log the model and the metrics. That's all. It won't register anything. The way these 2 Python scripts are executed are via a pipeline. We define a pipeline in Azure ML using a pipeline job specification. And in this case, we have 2 steps, one for preparation and another for training. This is a command job type. And essentially what this does is call the Python with some parameters. The first one is defining some outputs, because remember that this script will generate the data. So we need to output that data for the next step to read it. And both jobs are using a custom environment, and inside the conda YAML, we are specifying some dependencies required to execute those scripts. The next step, which is the training, is defining the inputs, and the path for the inputs are the outputs of the previous step. So that's how we pass the data from this script to the other one. Before I show you how these ML jobs are deployed using GitHub Actions, I will show you 2 additional resources that we have, which is the endpoint. This is the one that will serve the predictions for our model, but the endpoint itself won't do anything if we don't have a deployment. That's why we define 2 deployments, a blue and a green. And we have this to minimize the downtime because we can switch traffic between both. So the definition of the deployment is like this. Basically, we are specifying what is going to be the model, but this is going to change in the pipeline because this version is going to be updated every time we have a new version. From the workflow that we define, this number is going to be updated dynamically. We specify our scoring script, and also we have the same specification for the environment. In this case, we are of course serving traffic, so we're going to specify what is the VM SKU that we will be using. And finally, some liveness proof that the endpoint can do to check the health of the endpoint. The green deployment is going to be the same, just that they don't live at the same time. I mean, they can, but if they split the traffic. But in our case, we will be using one in 100 and in the other 0. So when the deployment for green is 100 but in blue is 0, we will deploy to blue, and then we switch the traffic to the blue, and then we delete the green. Now is the magic. When you push to main, the ML pipeline workflow is going to be executed automatically, but only if there are changes in this path. There is going to be multiple steps executed sequentially, so let me go one by one. The first step is the training. We will do the login, we will install the ML extension because that is not by default installed, and then we of course need to check that the infrastructure is created before we can just execute any pipeline. And the last step is the one that will execute the pipeline that I showed you before, where it has the preparation of data and also it has the training. So this will be triggering the pipeline. Well, if the metrics are met the threshold, they're going to register the model. If not, it is not going to be registered. And here in this second job, we check the quality gate for that model that we just deployed, because remember that we have a validation to check if the metrics doesn't match what we want, then we just don't register the model. So that's what we are doing here. We check if the model was registered or not. If it was not registered, we say just it was completed but it did not meet the thresholds, and if so, then we just up what were the, and if it passes, we just up what were the metrics. Now the deployment of the endpoint. If the model was registered and we are executing from the main, then we will execute this workflow. We will again validate that we have the extension and it is logging, and we will get the latest version of the model. This is why I mentioned that in the green deployment we have defined here, but this is going to be updated dynamically. That's why we get what is the latest version defined here, and we just output it in this variable called version. The next step is to check which of the deployments is active. Is it the blue or the green? If the blue is handling the traffic, of course we don't want to touch the blue. We want to deploy it into green, and vice versa. If we are handling the green here, we just say that the green is active and we need to deploy to blue. And if the other way, so we just validate that the blue is active and we deploy to green. The other step is to create the endpoint or update it if it exists already, so that this doesn't fail the next time we execute it. And in this step is where we will create the actual deployment to the endpoint. Do the deployment of the endpoint based on the target. So remember that we define here, okay, is it blue or is it green? So we just reference the file that we have. It can be this one or the blue one. And we are going to set what's going to be the endpoint name, what's going to be the model. You see, the model that we define in this is going to be updated. So that's why having it hard-coded here is not important, because in this case, we are just setting the latest version. We do then a final smoke testing of this with a JSON file that we have, which is here. Let me show you how it looks. So basically we have this data and it will give you 101. So it made those predictions against the model register there. If everything looks good is when we will shift the traffic from the blue to the green or vice versa. So here we say like, okay, shift the traffic 100% to this new deployment that we just did. And doing so, we ensure that we don't have downtime because we are not affecting the current one that is deployed. And also, if you want to test, for example, for a small percentage of your users, you can put it like 90-10 or 50-50. You can split that in whatever you want. And then finally, we just delete the old deployment. That's how we do the register of the model, the validation, and the manage online endpoint deployment for dev. The last part of the workflow is the promotion from dev to prod. And the way we are doing this is that we are downloading the model from the dev workspace and registering in the prod workspace. In this part, we check what is the latest version in the dev workspace. We downloaded it and then we registered in the production one. And the reason we are doing this one is because we don't have a shared registry. In a real world, what we usually have is a shared registry where the dev workspace pushes the model, and then the remaining workspaces just need to pull that. So this is the first job for the production deployment. The other one is the same or similar to what we did for dev. So what is that? We need to know what is the latest model version that is in the workspace. We need to check what is the active deployment that we will deploy into. It is blue or green. Once we have that, we will create the online endpoint or update the existing one. We will create the deployment, the new deployment, either for blue or green, depending on what is active, using the latest version. We do a smoke testing with the test request that we have, and if everything looks good, we shift the traffic. And finally, we delete the old deployment so we don't waste money because this is going to be inactive. So the good part of having a blue-green deployment is that we have almost zero downtime, because we are checking first that we passed the smoke testing before we shift the traffic. So if anything goes wrong during the smoke testing, the traffic is still being handled by the old deployment. And you can even go farther, and you can just keep both deployments running at the same time, and you can just roll back easily if you want. In our case, I am just decommissioning the old deployment to save money. So of course, this is a demo. This has basic quality gates, but in a real production, you could add as much as you want. This is the basic idea, and with this theory, you will understand every other setup. This is how the GitHub workflow looks from the UI. So we have the 3 steps that we defined: the training, the quality gate, and the register of the deployment. For the training, it just basically executes this command. This takes some time, that's why I execute it ahead of time. And for the quality gate, it checks if the model was registered. So I can see here, yes, the model was registered with this version. Now it passes to the next step, which will basically do checking what is the latest version. Then it's going to detect what is the active deployment. We'll create the endpoint. Then finally, it will deploy to the green slot. And finally, it will shift the traffic. And also check here the smoke testing for the test request that we did, 101. So it is working. And we just delete the old deployment. How it looks from the UI. So here we have an endpoint called churn predictor endpoint. We have the traffic currently is going to green, and you can even test it with the REST endpoint if you have the key to access it. Another part that I wanted to show you is how the jobs looks from the UI. So remember that we deployed the pipeline that defined in the YAML. So it's also showing this one visually with a dependency from the preparation to the training. I go to the training and I can check what are the values for each metric that we define. The production deployment looks a bit different because we don't have training in production. What we do is we promote the model from the dev workspace. So we get the latest from model and we register that model into the production workspace. And then the next step is basically the same that we did for dev. We get the latest version, detect the active deployment, create the endpoint, deploy the green, and so on until we just shift the traffic. And now if I go into the workspace, I can check the endpoint that was deployed. We have this green deployment, and we can again serve any predictions using this endpoint. I can check also here that there is no jobs that were defined here because we don't do the experiments here. We do it in the dev one. And finally, the smoke testing that we did is also working for the prod one. And that's it. That's how we deploy a complete MLOps solution in Azure, driven entirely by GitHub Actions. So let's recap what we built. And I know this is complex if you are doing the first time, but it's going to be more natural once you start doing it. And again, start simple and you can add more and more complexity to it, like this demo. We did 2 environments, dev and prod, with different resource group, different workspaces, and it was deployed using the same Bicep template. The only thing that changed was the Bicep parameters. The next step that we did was the OpenID authentication, so we didn't have to store any secrets in the GitHub repo. We then created an infrastructure workflow like a linting, validating, what if, deploy, and so on, so that we have the infrastructure deployment automated. We also have a ML pipeline workflow to train to do the blue-green deployment and also for the promotion of the model. I show you how the artifacts for the Azure ML looks like the pipeline that we define in Azure ML, the online endpoint, the deployments itself. We did a blue-green deployment, so we have zero downtime. We have also rollbacks easily. and we have an automated smoke test. And finally, we have MLflow tracking because we have full metrics and we are using a model versioning. So the best part of this is that you push the code and dev gets updated automatically. If we click promote, it will go from dev to production. Again, this is a simplified version, but you get the idea. If this was helpful, just hit like and subscribe. I'll be covering this type of topics in upcoming videos too. I cover also DevOps, Cloud, and MLOps. And drop any questions in the comments and I will answer them. Bye.